Hey guys, Mr. Backberg here. In this video, we're going to look at how differentiability implies local linearity. So a good way to think about differentiable functions is that they're locally linear. So that means as you zoom in closer to a curve at a specific x value of a, it's going to resemble its own tangent line. So if we had a graph with a whole bunch of curves in it, if we were to zoom in on any one of those curves, the closer and closer that we zoom in, the more line-like or the more linear that portion looks. And that line would have the exact same slope as the tangent line. So in this example, we're going to do some zooming in to see differentiability. So we're going to compare a couple of graphs. Our f of x function is going to be the absolute value of x plus 1, and our g of x function is going to be the square root of x squared plus 0.0001 plus 0.99. So I'm going to graph these out on my calculator. So in my calculator, I've got both of those functions typed in. I only want to graph out the y1 right now. So I'm going to arrow up here to y2, arrow over to the equal sign where it's highlighted, and hit enter. By unhighlighting that, that means that it's not going to graph out that function yet. So if I hit graph, we're going to get that graph for our function f. And it's an absolute value graph, which means that it's going to be v-shaped. So there's a corner happening right here at the x value of 0. And if we zoom in on that, it makes it even easier to see that corner. And we said that a function is not differentiable if it comes to a corner because the left-hand derivative and the right-hand derivative are not the same. But now let's take a peek at that other function. So I'm going to go back to my y equals. I'm going to turn off this absolute value graph, and I'm going to turn on this other graph. Now I'm going to do zoom 6 to get my 10 by 10 window. Now this graph looks exactly the same as that last one that we just took a look at until we start zooming in on what's happening at the x value of 0. So if I zoom in closer there, it still kind of looks the same. But as we get closer and closer, we can see that the graph is actually rounded at the bottom of that curve. So it's not truly a corner, and in fact, at that x value of 0, we'd have a flat horizontal tangent line. So this function is differentiable there. Even though it initially looked like there was a corner happening at that x value of 0, there's not because we zoomed in and saw that the graph was rounded off. That's going to be it for this video. Thanks for watching.